Hi, welcome to our math. Today I'm doing a series of videos on exponents and how to simplify kind of crazy expressions. For my first example, I have k times k cubed to the 10th. The first thing you have to remember is every base has an exponent. So even though this says k, it's really k to the first power. And what's happening if we expand this is we have 1k times 3k's. And if we add all this together, we really have 4k's. So the rule says if the exponents are attached to bases and the bases are the same and you multiply them, you add the exponents. But like distributing into parentheses, if the number is attached to the parentheses, you multiply. So this becomes k to the 4 times 10 or k to the 40. For my next example, I have two problems without any exponents attached to the parentheses, but now I need to combine same bases. One issue I often see is in a case like this where it's mn to the 5th, a lot of times people want to assign that 5 to both the m and the n. The problem is if I wanted to do that, I would have to attach the exponent to parentheses to distribute across more than one base. So I can't do that on this case because each base has its own exponent. So once again, coming in and putting a 1 right here can really help us see we have three bases. The numerical base, 12 times 4, negative 12 times negative 4, m to the 4 plus 1, and n to the 2 plus 5. Once again, we're adding the exponents because there are two n's, and each n has an exponent, and when the exponents are attached to same bases, you add them. And you can always expand to double check. All right, a negative times a negative is a positive, so we have 48, n m to the 5th, n to the 7th. All right, my last example for this video is, once again, an exponent attached to parentheses with three bases. The biggest mistake I see on a problem like this is for some reason the number isn't given the exponent. You could think of this as being 7g to the 9th h to the 6th times 7g to the 9th h to the 6th times 7g to the 9th h to the 6th. That's what that cube means. It means this whole parenthetical phrase is happening 3 times. Instead of rewriting it like that, I prefer just to distribute that exponent in. Now we can distribute in because everything in the parentheses is multiplication. If you think of math as a hierarchy, I always talk about math world, you can think of multiplication and division being one family, and exponents work for multiplication and division. And as long as everything you're doing is multiplication and division, the exponents are nice. It's when you bring in that addition and subtraction that things get interesting. And whenever an instructor says interesting, that's when you really need to perk up and pay attention. We don't have pluses or minuses. We have negatives, but that's not pluses or minuses. So this cube gets distributed in. There's an implied 1 there. So I have 7 to the 1 times 3, g to the 9 times 3, and h to the 6 times 3. As for this first one, 7 cubed, when I have a number to an exponent, my general rule is if the final number is less than 1,000, I usually multiply it out, regardless of if I have a calculator. If the answer is going to get into that 4 digits, then it's a little iffy as to, are you going to leave it exponential or are you going to expand it out? I'm going to expand this. 7 cubed is 343. I always appreciate a good palindrome. 9 times 3 is 27, and 6 times 3 is 18. I hope you've enjoyed this video. I hope you enjoy all my videos. Subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!